do better too.
Later. I'm scared. What if it doesn't work?
It's going to work, Chappie. I promise.
And you can never break the promise.
Come on, listen.
Buddy, gotta love robots. That's what we're gonna build now, guys. Budget robot build. So before we get started, you know, we need to go over the parts. So in this project, which will be a 3-part series, I'm gonna go through, you know, from the start to finish on building this robot. So I'm trying to keep it as cheap as possible, and this is sort of what I've come up with. So let's go ahead and get started. You're gonna need a 9-gram servo, HC SR04 ultrasonic rangefinder sensor, and the accompanying bracket. You're gonna need a L289N motor controller driver, buck converter, a bunch of these female and male DC power connectors / cables. You're also going to need a breadboard. Right here I have a micro size or mini breadboard, but I think half size would work too. Also, you're going to need a 16 channel servo controller to control the 9-gram servo. You're gonna need a bunch of jumper cables. I have assortment here, so female to female, female to male, male to male. And then below, under that, I have a 12-volt power source, so that's the battery pack. You're gonna need a Raspberry Pi 3, company SD card, a Raspberry Pi camera, a DC power supply to sort of test things. And finally, you're gonna need a 4-wheel drive robotics kit. So if we start breaking down the price, we've got, this is a rough estimate, so got the 9-gram servo, $8, HC SR04 sensor, $12. And I'm going over the price of, sometimes some of the sensors come in packs of more than one. So this is a rough estimate. You can probably get it cheaper, or you may encounter things that might be slightly more expensive. You know, your mileage may vary. Brackets, $8, L298N motor controller, $12, DC connectors, $3, buck converter, $11, breadboard, $8, 16 channel servo controller, $9, 12-volt power source, aka battery, $34, jumper cables, $4, Raspberry Pi, $39, SD card, $10, Raspberry Pi camera, $15, DC power supply, $13, and the robotics kit came out to $19. So in total, all of these parts cost $215. So our budget build price is a little over $200. So now you may be asking the question why I'm going to be building this robot. So I came across this challenge / contest on Instructables for microcontrollers. So the Raspberry Pi 3 fits in there really nicely, and I thought, you know, this sort of ties everything together of all my previous videos. So we're going to use you know, the L298N to power these 4 motors. We're going to use a servo with the 16 channel PWM servo controller, and then the ultrasonic rangefinder. And yeah, so that's that's the goal. So some of the features for this robot, we're going to define the scope here. I want the robot to be remote control via Wi-Fi through SSH, you know, have the ability to live stream video from the Raspberry Pi camera, and finally implement a crude obstacle avoiding AI mode. So essentially we hit a button and give the 4-wheel bot the ability to wander around and avoid obstacles. So yeah, with that said, let's go and start this build. I'm gonna go ahead and open it up and start putting it together. So now we got the two sort of plates here. I'm gonna go ahead and start peeling this. Okay. There's two little holes. I just gotta find where they line up. So I'm gonna assume they attach to the bottom. That's actually a lot more faster to do. So I'm gonna go ahead and just get all of them started. Here and cheat a little bit. I got my electric drill. Moving on to the next set. And the final standoff. Right here. You're gonna take this, slap it on here, take these long screws, sort of fish them through the hole and into the motor casing, and then do the other one as well. Boom. So that sort of gives you a rough idea of how they'll be mounted up. And then now we can just attach these nuts. So like I did previously, I'm just gonna go around and hand tighten these. Let's do the next set. Okay, upon further inspection, it looks like there are some seriously big quality control issues with this kit. First of all, we need 4 standoffs and there are 3. There's one more motor and I only have 1 long bolt and 1 nut. So we're short a bolt, a nut, and a standoff, which is great. On the part shortage, I have managed to scavenge an extra long screw, but I don't know if it's still a little bit short, so hopefully we should be able to make it work with 1 screw. But for the 3 standoffs, I think we'll just have to use a triangular pattern and then hope that holds. I really don't know what else to do. I don't have an extra hex standoff thing. So let's go ahead and just keep on trucking. So we'll just do, and we can like glue it on later. Sweet. And then hopefully, I don't know if this is gonna come through because this metal standoff is like, should be good enough for now, at least. And then now we need to route some of the wiring. So I'm thinking we're gonna put the motor controller, we can either put it up here or down here. I kind of like keeping it down here, but I don't know if it'll clear. So I think a better test is let's put the wheels on and see how much space or clearance we have, and then based on that we can make a decision on, oh shoot. So yeah, I gotta tighten some of this stuff down before we get started. Really? I feel like we're running into quality control issues all over the place. Come on. There we go. Boom. Get this wheel in. Oh, whoa. 2. Okay, we know that this one's gonna have big issues, so I'm gonna hold on to that. Come on, buddy. 2, 3, and all right, awesome. I've sort of mocked it up with everything, all the components in place, and I think this should work. So pretty much we're gonna have these motor wires sticking up from the sides, and I might have to elongate them a bit so that they can reach this motor controller. This will be plugged into the Pi. The Pi will also be connected to this breadboard, and that's for the sensor, the ultrasonic sensor, and then I will just take this PWM controller and just mount it on this other half, and it should work. I think in theory. So we got motors on the bottom level with the wheels. Middle layer is the battery pack, power, and then the top holds all the electronics. And then finally for the sensor here, I'm thinking instead of mounting it vertically, because since it'll be so high up, it's gonna miss anything that's under here. So if we turn it upside down and somehow mount it like this, like so, I think that should do it. Fabricate a mount to stick it out some. So now that we have an idea of what needs to be done and how it should be assembled, I'm going to go ahead and start insulating all the electronic components on the bottom. So you could theoretically just use electrical tape to cover these end bits, because when we sort of mount it on this device like so, I'm going to use some double-sided tape. but I don't want to create any shorts. So to ensure that, I'm just going to use this liquid electrical tape and just coat the bottom. So yeah, I highly recommend this stuff. It's great because it dries super hard and it sticks really well. And I've shorted like 2 or 3 of these, so I know from experience, like, best to just go ahead and do that. Now you could snip these ends off, but I don't really enjoy doing that because you get all these little sharp metal pieces everywhere. So much rather just coat this icky stuff. Let me get something so I don't mess up my workplace. I'm just gonna go here, just brush it on. Just gonna go make sure everything is really coated. Yeah, it looks pretty good. Oh yeah, and another tip is probably don't like cover the labels or the outputs, because you probably need to know that. Luckily I have more of these on hand, but yeah, just something to keep in mind. But go ahead and do this for your motor controller, your servo controller, and those are the 2 main things. The Raspberry Pi, I just wouldn't, probably just use electrical tape for that one. But yeah. Okay guys, now that we're back, I've gone ahead and let this liquid electrical tape dry on the motor, driver, and the servo controller. So now we can flip them over and then sort of just double-sided tape them down to the acrylic platform. So now that you have that done, you can move these to the side. So the next step, we gotta desolder these wires and make them longer. So I'm gonna go through that now. We're gonna essentially replace each black and red wire with another electrical wire, but this time it'll be a bit longer. So in order to run these new wires properly, they need to be at least 8 inches or so. So we're gonna need 4 of these. So I'm gonna go ahead and get that done. I have my trusty wire spool here. So you want to leave roughly, I want to say like a 1/4 of an inch strip. So I'm going to go ahead and do that. It doesn't have to be perfect, but you want to have enough so it So go ahead and twist these ends to keep them super tight. Just makes it easier to work with down the line. And since they're going to do that to each side, so this might take a little bit. Okay, all of our 4 wires are done. Do a little cleanup here. Okay, now that that's all the wires are stripped, I'm gonna go ahead and tin the ends. So I'm gonna go ahead and kick on my soldering iron. So safety first, guys, make sure you have adequate eye and face protection and adequate ventilation. So I'm gonna kick on my extractor fan here. Okay, so it's now time to desolder the motors. In hindsight, we should have done this before mounting it to the mounting brackets, because it's gonna be hard to get sort of the ones close to the acrylic. Might be a little bit melting, but I'm just gonna have to go ahead and do it. Yeah, so here we go. Okay, now we've got all these set up. I'm gonna go ahead and hit it with some liquid electrical tape real quick to sort of insulate these wires a little bit better. So let's go ahead and do that. We're not gonna need much, so less is more in this case. So you just kind of want to go over anything that is sort of very exposed. So it looks good for that one. Underside a little bit. So these two are good. Those dry for a quick second. Get a tad more product on the brush. So hopefully this wiring is good. We haven't really tested it, but confident in my soldering ability. If you're new to soldering, I would say, nothing substitutes experience, so this is like a good platform to learn on. We'll probably do some troubleshooting later down the line in the tutorial, so I'll show you how to use a multimeter to read the voltages to check to see if you have a bad connection. So that looks pretty good. Get this one a little bit more. Alright. So I got this last piece. Ugh. That was a pretty big globe I put there. Alright, and that's it. It looks pretty good. Okay. So now we have longer wires on the motor. They're insulated. Now we just need to go ahead and remount. So now that we've pretty much back at where we started with the new longer wires attached, I'm gonna go ahead and test the motors real quick. So I have this 9-volt battery pack. So let's go ahead and see if each of the motors kick on when power is applied. So I'm just gonna take these here and sort of just jump them. It's probably not the best way to do this, but so that one's good. Let's do this one. It's good too. Looks like we're doing a good job. This one here and this. Oh, we're gonna flip this over, duh. We're really gonna spin. Just gonna take this. Ugh. 1, 2. So that motor works as well, and we have one more motor test, and then we know for a fact everything is working. Everything is working! It's a good sign, guys. We're one step closer. Whoa. That one is not spinning straight. We may have problems with that. I wonder what the issue is. Let's try it one more time. Yeah, that wheel is not balanced whatsoever.